Hello dear students, let us solve a numerical problem related to Bohr's theory of hydrogen atom. The question is, two electrons 1 and 2 are revolving through two orbits as shown in figure. A. Which one is greater, V1 or V2? B. Which electron has greater angular momentum derived? C. Where does electron jump to get lower velocity? Here, this is the diagram in which two electrons 1 and 2 are moving in circular orbits of radii r1 and r2 respectively with velocities v1 and v2 respectively. If q is the charge of the nucleus, then as we know, centripetal force is provided by electrostatic force. Therefore, 1 upon 4 pi epsilon naught q1 into E upon Rn square will be equal to mvn square upon Rn, where Rn is the radius of nth orbit in which electron is moving with velocity vn. Here Rn cancels out and we get vn square as q into E upon 4 pi epsilon naught m Rn. Hence v1 upon v2 will be equal to root r2 upon r1, which shows that v1 must be greater than v2 because r2 is greater than r1. Therefore v1 must be greater than v2. Now second part, angular momentum denoted by L is equal to moment of inertia and angular velocity omega, moment of inertia I and angular velocity omega. So I is equal to mr square and v is equal and omega is equal to v upon r. So it becomes m into v into r. Therefore, in nth orbit, angular momentum may be denoted by Ln and it will be m into Vn into Rn. And from Bohr's second postulate, it is quantized, that is, it is integral multiple of h upon 2 pi. So Ln will be equal to n h upon 2 pi is equal to m into Vn into Rn. Hence, L1 will be equal to 1 h upon 2 pi and L2 will be 2 h upon 2 pi. Thus clearly L2 is greater than L1. Hence angular momentum of electron 2 is greater than that of electron 1. Third part, as V is inversely proportional to R, therefore electron must jump to higher orbit in order to decrease velocity from this relation.